Hello, I'm an old guy and I do maths. Today we are looking at the quotient rule. Yet another rule to assist us with the speedy resolution of derivatives. And as the title implies, this is when you have one expression, or one function if you want to call it that, although that's not strictly true. We'll say one expression divided by another, and there's no sort of easy resolution of that. Okay, so it is the case where we have expression u divided by expression v, and we are looking for the derivative of that. An essential element here is that v cannot equal 0. There's no future there. So let's look at the rule. Those of you who have seen the chain rule and hopefully the product rule will see some elements in this that look vaguely familiar. Those of you familiar with the product rule will be familiar with the idea of splitting our problem up into u and v. Those of you who've only seen the chain rule, it's an innovation, but you will be familiar with du dx and with the idea of u. Anyway, the quotient rule says that the derivative is equal to v, the denominator here, times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. Now, as I say, those of you familiar with the product rule will see some really striking similarities here, and if you're unfamiliar with the product rule, I'd suggest you go and have a look at it. There's a video in this playlist on it, and it contains a worked example, as will this video. And let's get to that. So let's have a look at the sort of thing that we might be dealing with. Let me get all of that in the frame for you. So here's our expression, and we want to find the derivative of this. X minus 2 all over 3x squared minus 2x plus 9. Right, well, let's get sorting out what some things are. So u is x minus 2. So x minus 2 would fit into our formula, into our formula here. The derivative of this, hopefully you understand, is 1. So the derivative of du dx is equal to 1. The derivative of u is equal to 1. The derivative of u with respect to x is equal to 1. It's quite a mouthful. V is our denominator. It's there. The derivative of that is 6x minus 2. And the next thing we're going to do is we're going to plug all of this in, which I have done already, and I'm just going to talk you through this. So here is v, the denominator in our expression. Here is the derivative of u, and we are subtracting from that u, which is this, times the derivative of v, which is this. So it's important to set this out as neatly as you can. Shortcuts here really do cause trouble. Okay, and that is all over v squared, which is this expression here squared. And quite often when you see examples of the quotient rule, you'll see this just left as v squared, because it's considered too much of a pain to expand. And after all, what you're looking at getting is a derivative that you can use. So it doesn't necessarily have to be completely, this for instance doesn't have to be completely expanded. You can insert values and square. It's generally textbooks that demand that you go to the nth degree with sorting out expressions like this. what you want is you want a good working derivative that you can use. Okay, so that's the setup here. Now let's have a look at how we start simplifying this. Okay, so what I've done here is I've taken away the explanations of things, and the main thing I've done is expand this expression. So that's here. Okay, so what we wind up with as a numerator is 3x squared minus 2x plus 9. You'll recall that the derivative of u is 1, so that just stays as it is. And this is the derivative of v times u, which is another quadratic, and I've left the denominator alone. Now, a little bit of sorting out. 3x squared minus 6x squared gives me negative 3x squared. Negative 2x plus 14x gives me positive 12x. 9 minus 4 gives me 5. That's our numerator. And here is the denominator. And this is the derivative of x minus 2 over 3x squared minus 2x plus 9, found by using the quotient rule. Now, as I've said in my video on the product rule, you're going to find that sometimes other rules make their way into this. So sometimes you're going to have to do some work with the chain rule, for instance, in order to get to a point where you can use the quotient rule. Just be aware of that. This can, on occasion, wind up as pages and pages and pages of working. I have a lot of white lined pads, and I can remember on one occasion having to go to the stationers and get some more of these pads so that I could keep working on a derivative that involved the quotient rule. Anyway, thank you very much for watching. I hope that this was a gentle enough introduction to the quotient rule, and that the example was straightforward. There will be further examples. We'll do this with some of the more challenging derivatives as well. I'm thinking E and maybe a few other things. Okay, thanks for watching. See you next time. Bye-bye.